The slope of the least squares regression line from the golf data that we found was 3.1661 yards per miles per hour. List two interpretations of the slope that are acceptable. So one is if the club head speed increases by 1 mile per hour, the distance the golf ball will travel increases by 3.1661 yards on average. Another interpretation, if the club head speed increases by 1 mile per hour, the expected distance the golf ball will travel increases by 3.1661 yards. The keywords here are the expected and on average. When you are doing this to interpret a different slope, just kind of match up with where these are going for the y and x axes. Before you interpret the y-intercept, you need to ask yourself two questions. Is 0 a reasonable value for the explanatory variable, otherwise known as your x? If not, then you don't need to interpret the y-intercept. Same for the second question. Do any observations near x equaling 0 exist in the data set? If no, you don't have to or you cannot interpret the y-intercept. So ask these questions first before you put the work into interpreting, because you might not have to interpret the y-intercept. And what does it mean to say that we should use the regression model to make predictions outside the scope of the model? That we should not use the regression model, sorry. We should not use the regression model to make predictions for values of the explanatory variable x that are much larger or smaller than those observed. So, for example, in the golf data, we range between 99 and 105 miles per hour. It would not make sense for us to make a prediction on, say, something at 5 miles per hour, because that's not where we observed any of the speeds. And we couldn't say or predict something above 105, so say like 300. That would not make sense to do that either. When the correlation coefficient indicates no linear relation between the explanatory and response variables, and the scatter diagram indicates no relation between the variables. So what that just means right there is we have just plot points all over. So now it's asking, how do we find a predicted value for the response variable? So we don't have an equation for a line because they're all over. So what are we going to use? What we're going to use is y bar. We're just going to use the mean for your y variable, because having some kind of a line to form to the data to predict is not going to be good because there is no relation here. So we use the mean value of the response variable y bar as a predicted y hat. So again, if there's no relationship between the variables, so that means your r is going to be very close to 0, you're going to use your y hat or your y bar as your predicted y hat. Let's look at an example. The table represents the age for a randomly selected student and their number of siblings that they have. Analysis of the data reveals a correlation coefficient of R equaling 0.0369. So let's just stop there. What I did is I entered the data into the list. And you can follow list 3 on your calculator sheet like I had showed you before. If you go to calculate and then 4, you can see that our R is the 0.0369. So that's very close to 0. So when that happens, you're going to want to find y hat. So what is y hat? So we are looking for the predicted number of siblings. So siblings is what we're looking for. So that's our y. So what you could do is add these all up and then divide by 5 because there's 5. Or if you want to use your calculator, you can go to Stat, Calc, and it was in list 2, the siblings, and you should get your average to be 1.8. So no matter what age you pick, the predicted, the y hat means predicted, it's 1.8 siblings. So what would be the predicted number of siblings for a student who's 20 years old? 1.8. What would be the predicted number of siblings for a student who's 35 years old? 1.8. It's just a straight line across of 1.8 as the predicted.